I'm teaching C# to beginners, and when we get on to conditionals and if statements and that sort of thing, one of the things that people often want to do is write some code looking a bit like this, where we can say something like, here we've got a variable x that's an integer, and they would like to say if 10 is less than x is less than 30. So if x is lying within that range of 10 and 30. And as you can see from this C# code here, that is not something that's allowed, it's giving us an error. But it is quite a natural thing to want to be able to do, because certainly in mathematics we write expressions looking like that, and in fact in other programming languages we can also do that sort of thing. So if we take a look, say, at some Python, so here is that equivalent program in Python, and there we've got the same thing, asking if x is in the range 10 to 30, and then we're calling this function with 3 possible values of x, so 5 should be too low, 20 should be just right, and 50 should be too high. And if I run that up and just drag over the window, there we can see 5 doesn't match, 20 does match, and 50 doesn't match. So that works well in Python, which is possibly one of the reasons people want it in other languages. Now, this has always been a bit of an oddity in C-style languages, because if we do that similar sort of code in C++, or indeed in C, then we get some really weird behavior, because here we've got that same sort of thing, our integer x, and then putting it in the range 10 to 30 and trying it with those same values, and it looks like everything's happy with that. But if I run that one, we can see that it actually matches every time. So remember, it should have been doesn't match, matches, doesn't match, but all of them match. And that's because of a strange thing that happens in C and C++, which is when we have an expression like this, the first thing that gets evaluated is that sub-expression there. So 10 is less than x. And obviously that's either going to be true or false. But then in C and C++, the true or the false will get implicitly converted into an integer, which will be 0 for false and 1 for true. And so that whole expression that I've got highlighted there becomes either 0 or 1, which is clearly less than 30, and so that's why we get matches every time. So that's a really nasty feature of C++ and C. If we just do a complete rebuild and look at the error list, we'll actually see that it's giving us a warning about that, saying that it's doing this conversion of bool to int. But it's only a warning, not something you'd necessarily notice. But in C#, thankfully, it's definitely an error, and this is one of many, many improvements that were made when C# was written to address issues that were there in C++. So what we mean by this in C# and how we should write in those languages would be something like this. We're trying to say if 10 is less than x and x is less than 30. So it's not very difficult to put that in C#, and then we'll get the same sort of results. Doesn't match, matches, and doesn't match when we pass in those 3 values. So it's not an awful problem, but that's always been the way you had to do things to do it correctly in C# since the beginning, until C# version 9, because in C# version 9 the idea of relational patterns were introduced, which allows us to do something similar. It doesn't allow us to write precisely that syntax that we want, but what we can write is something like this. We can say if x is, and then say greater than 10, and notice it's a keyword and, not the double ampersand you might otherwise have, less than 30. So it's actually not saving any typing compared with doing it in the more old-fashioned way, but it's just showing this new feature we have in there. And so now we are saying x is the thing we're testing both times. So if we run that one up, we'll now see it runs and it gets that correct behavior, so the middle value is the one that matches. There's all sorts of other things we can do with this. We could say something like it's greater than 10 and less than 30, or 5. So now we're saying either it's in the range between 10 and 30, or if it's got the value of 5, then that will match as well. And again, if we run that up, we now see we get that matches on 5 because it's hit with that. Or we could do something like x is greater than 10 and not less than 30, in which case we would get doesn't match, matches, because the 20 is less than 30. So various things you can do. We've got is, we've got and, we've got or, and we've got not. There's one slight limitation that we have on there though, and that is that the things we're comparing with, the 10 and the 30 in this case, have to be compile time values. So if we go back to the Python, I could make a slight change here. I could pass in A and B, and then compare with A as the lower limit and B as the upper limit, and then in here, every time make that comma 10, comma 30. So same values as before, but passed in as parameters. And that works in exactly the same way. So we're getting the same results. But if I were to try to do that with C#, so if we put in here int A and int B, and then put those in there, then we can see we're getting errors because a constant value is expected. We could, of course, have done that with the A is less than X and X is less than B. So it is possible to do it the old-fashioned way, but with these relational patterns, you've got to have constants for the things you're comparing with, apart from the one variable that you're looking at. Now let's take a look at a slightly more interesting example of that. So I will comment all of that out and then uncomment what we've got down here, because what I've got here is another look at the book reviews that we've seen in various videos I've been doing, just by way of an example. So we've got this idea of a book review which has a title and a rating, and remember, individual books can have a rating 1, 2, 3, 4 or 5, so it's got to be an exact number. But once you accumulate a load of ratings, you're going to get decimal points in there when you've done the averaging, and so that rating can be a double. And what I've got at the moment in the program is this toString that prints out a title and a description, but at the moment that description is just the rating, so that's all we've got there. And so if we just create some made-up books and we print all of that out, then we're just getting the average ratings that I've made for those books, all working fine. But what I want to do here is not have those average ratings, but simply to summarize the ratings so we can have different words describing different levels of quality. So if we look at this ratings enum, what I want to have is rubbish, poor, good, excellent, and superb. But remember, because we've got these average values, those can't map on simply to a simple integer. They've got to map onto a range. And in fact, in this test code, I've put what I want to have in there. So what we want to do is anything that is greater than 4 should be superb. Anything that is between 4 and just greater than 3, we want to be excellent. Then in the range, anything greater than 2 up to 3, we want it to be good. Anything above 1 and up to 2, we want it to be poor. And then if it's only 1, we want it to be rubbish. So notice the important thing to test here is those corner cases, because we're saying that 1 is rubbish, but 1 point anything takes it up to the next level of poor. And then finally, we've got a couple of tests that are just checking for exceptions. So if we're above 5 or if we're below 1, then we just get an exception, because that shouldn't happen at all. And obviously at the moment that's not going to work, because we're simply printing out the actual average, not the label to describe it. So we can see there that's not coming out correctly. So what we need to do is put in some code for that. And so the way we'll do that, let's go to our book review summary, and in here I'm going to do this in what I'd say is the obvious straightforward way. So I'm going to say public ratings, so that's our enum, remember, and I'm going to call this rating by if else, which is going to be, as I say, the normal way of doing it. And then we'll just put in a get in there, and on that get say if rating is greater than 5, then we're going to throw a new argument out of range exception, and then let's just give that a message of rating out of range. Then I'm going to say else if rating is greater than 4, then I return ratings dot superb. And then if we just copy that down, then we can have 3, 2, and 1, which are going to go down as excellent, good, poor. And then we're going to have else if, and then rating equals 1, and that's going to return rubbish. And then we've got to have our safety check. So if it gets that far, then we're just going to throw that same exception again. And so that now should do that correctly. If we pop in that, so change that to rating by if else. And then if we run the tests again, then we see they're all passing. And if we run the program again, then we see we're now getting Dr. No, poor, Goldfinger, superb, etc., etc. So that's done what I want to do, and that, I'd say, is the obvious, straightforward way of achieving it. But something, again, that I tell students in introductory courses is whenever you have an if-else chain looking something like that, you have a slight potential issue in terms of performance, in that although if we had a rating of greater than 4, we'd only have done 2 tests to get there. So we'd check it wasn't greater than 5, check it wasn't greater than 4, and then go in there. But if it was further down, it's got more tests to do. So a poor book is going to have been tested more times than a good book. And so that means that it could slow things down and you'll get different performance depending on what the rating actually is. Now, what the optimizer does to get around that could be quite clever, but certainly it's a bit of an objection. And also, it's not very tidy to have this big, long if-else chain. And so what you often would like to do, instead of having an if-else chain, is have a switch statement. But the problem here is that we are not testing for discrete values, which is what switch statements traditionally do. We are trying to test for ranges, and so in older versions of C#, we'd have been stuck with doing it this way because we're not just looking for a rating equals 4, which you could do in an old-fashioned switch statement. You're looking for it in the range 4 up to 5 and so forth. So that's not so good. But now that we've got these relational patterns, we can actually use those in switch statements. So let's do that. Let's put in another way of doing this. So we're going to have a public ratings, and this I'm going to call ratings by pattern. And on this one, I'm going to use a switch expression that can use this pattern matching. So what I'm going to do is have a rating, which remember is simply our property, the double, and I'm going to switch on that. And then in my switch, I'm going to firstly have the relational pattern simply greater than 5. And in that case, I'm going to throw an exception. And then I'll have a greater than 4 is going to give ratings superb. And then put a few more of those in. So we'll go for a 3, a 2, and a 1, which we're going to be excellent, good, poor. And then, got to be a bit careful here. You might be tempted to put equals 1. But actually it doesn't like that. All we need to do is put 1 in there, because that's what we're saying. We're just saying if rating is 1, and that's all we need. So on that one, we give that the rating of rubbish. And then we can have our default, and let's just take that same code we had there. And so now that should all be working fine. And again, we can test that, because if I take these ratings by pattern and pop that into the actual toString, which is what we're testing against, and then run that, we should hopefully see that we get green lights again. So that's working in exactly the same way. And if we run the program, we can see we're getting the same results there. So that's what we have for 2 alternative ways of doing things. And certainly by looking at that, I would say that using the switch with the pattern matching is a much neater way of going. It's much easier to read what's happening in that code once you're familiar with this bit of syntax. Obviously, both of these, whenever you see a switch statement or an if statement, sometimes you regard that as a bad smell in the code, and you might be thinking, shouldn't this be done with polymorphism or something like that? But I think here it's reasonable. But once you've made the decision that either of these is reasonable, then I think it's better to go with the pattern matching. And it's got some really clever things it can do here. For example, if I were to change that 4 to a 6, we can see that we're immediately getting an error, and if we look at that error, it's saying that that pattern is unreachable because we've already got one for greater than 5. So there's quite a lot of good logic going on in there to make sure that it behaves in the correct way. One other thing we can actually see in both of these that's a bit irritating is that we've got the throw repeated, and it might be nice if we could put them all in the one place, but it would hit us with a problem that if I were to try and say just remove that, then 5 would now hit the is greater than 4. So if we look at the tests for that, that one's failing again because the too high actually is going to bring back superb. So if you did want to do that sort of thing, you'd have to have it a bit more complicated. So we'd be saying something like less than or equal to 5 and greater than 4. And in fact, we'd have to do that on all of those to get this working logically. But if we do that, that's now going to correctly get the error on the high and on the low. And so we're getting that working okay. Though, I have to say, again, until you're used to this, it does start looking a bit weird because you've got the equals greater than as your arrow operator, like the lambda symbol, and then you've got the less than equals, which is the mirror image, but that's doing something completely different. That's just doing your comparison on the rating. But still pretty neat for this sort of situation. Traditionally, as I say, switches are for discrete values, but now we can have a switch on a range, or indeed on all sorts of other criteria, whatever we want to put together. The final question you may be asking yourself, though, is what about performance? And as I mentioned, the issue that you sometimes have with a long if-else chain is it takes longer to get through to the end than it does to test something at the beginning. Well, we know how we can measure performance because, remember, we have benchmarking. And so let's put in some benchmarks and see how this is all going to work. So what I'll do is add a new class that I'll simply call benchmarks and make that public. And then what I'll do is put in a public ratings that I'll call if else. And what I'm going to do with that is create a book review. And I'm going to just give that a random title for the book because that doesn't matter. But then I'm going to give it a rating, and actually we'll have a property in there that I haven't written yet. And then I'm simply going to say return review dot rating by if else. And then let's do another one of those for the pattern. So we'll just copy that. That's now going to be called pattern. And we'll say rating by pattern. And then this rating property, so we'll have a property of type double that I'll just call rating. And then if you remember what we did in the benchmarking video, I can put params on here. And then let's test that for ratings of 4.5, 3.5, 2.5, and 1.5. So remember, we're saying that the theory is it'll have different performance depending on whether it matches early or late. So those values will help with that. Let's just add in the namespace. So benchmark.net, I've already added the NuGet package. And then also we need to put that benchmark attribute on each of those. And remember, with the benchmarking, we can have a baseline, and because I think the pattern matching is the better one in terms of the look of the code, that's the one I'll make the baseline. So we'll just say baseline equals true. Okay, and then all we need to do is in our main, we just need to run that. So in program, let's get rid of that. And then we've just in here got to say benchmark runner, get hold of the namespace, and then say dot run, and then generically put in the name of the class. So that was my benchmarks, and that should be getting it all right. Then we've got to remember to set the build to release so that it optimizes, and then if we just run that up and wait a long time, which I will cut. And the very first thing to notice is there is not very much to choose between them. So we're getting the result for the if-else. They're in between 0.94 and 1.09 of the baseline we have for pattern. So that's not a huge amount of variation. What we might have expected is that it will be going quicker on a high rating because that is earlier in the chain, whereas lower ratings will be slightly slower. And you might see that that's been borne out. So certainly the worst one for the if-else is on the 1.5. The best, though, is on the 2.5. So there's clearly quite a lot of variation going on in there. And I think we can expect there's huge amounts of optimizations done by the compiler that really makes these two end up pretty similar. Certainly, I wouldn't be worrying about the performance difference with those kinds of numbers unless it was really something that was starting to hit me. What's important is the style of the code, and I think most people would agree that once you're used to this new syntax, then it's just much neater to be able to put that in the switch statement using the relational patterns. So that was it, just a quick look at this C#9 feature, relational patterns, which we can use in if statements, though I think probably I'd stick to just the more traditional way of doing it in most cases there. But when it comes to something like a switch statement, that really is a big step forward in terms of the tidiness of our code. So I hope you enjoyed that. If you did, do click like, do subscribe, and I'll see you next time.